Back in 2017, a team of researchers at Google dropped a paper with a title that sounded, I don't know, almost like a pop song. Attention is all you need. But this wasn't some catchy tune. This was the quiet spark that basically ignited the whole AI revolution we're living in right now. It wasn't just another small step, it was a total rethinking of how machines could ever understand human language.
Right there in the abstract, this one sentence just threw down the gauntlet. They weren't just suggesting a little tweak. They were basically saying, hey, you know that entire playbook everyone's been using for years? Let's just throw it out. And they were going to replace it with something built on one single powerful idea: attention.
So, okay, what's the big deal here? Why was getting rid of this thing called recurrence so important? I mean, to really get why this was such a breakthrough, we have to look at the huge wall that everyone in the field was running up against. And that wall, that problem, was what you could call a sequential bottleneck. It was all about the way the best models at the time worked. They were called recurrent neural networks, or RNNs. And look, for years, they were the absolute best tools we had, but they were seriously starting to show their age. Just imagine trying to read a long book by looking at it through a tiny peephole, one single word at a time. That's kind of what an RNN was doing. After each word, it would try to remember what it just saw and carry that memory to the next word. But you can see the problem, right? By the time you get to the end of a long paragraph, your memory of what happened at the beginning is going to be pretty fuzzy. It just couldn't connect the dots between ideas that were far apart.
So here you have it, the two big ideas head to head. On one side, you've got the old way. Slow, one by one, and it forgets things. On the other side, you have this new idea, a model that could see all the words at the exact same time. This wasn't just about being faster, which it was, way faster. It was about solving that whole memory problem in one brilliant move.
So, how do you do that? How would you actually make a model see an entire sentence at once? Well, this brings us to the absolute genius at the heart of the paper. The solution was a mechanism that had kind of been floating around before, but now it was about to get its moment in the spotlight. And that mechanism was called attention. The authors asked a pretty profound question. What if, for any given word in a sentence, the model could just look at all the other words at the same time and just calculate how important each of them is to understanding that one specific word? What if it could figure out the entire web of connections all at once? And that is the magic trick right there. They called it self-attention. The model literally pays attention to itself. It's all about connecting different words inside the same sentence to build a much, much richer picture of what's going on. It learns context by looking at the whole forest, not just one tree at a time. Now, this powerful idea wasn't just some theory they wrote down. Nope, it became the foundation, the very bedrock of a totally new model architecture. And folks, that model is the hero of our story, the transformer. All right, here it is, the original diagram from the paper. I know, it looks a little intimidating, but trust me, the design is actually super elegant. Think of it like this. The encoder on the left reads the sentence you give it and uses that self-attention trick to really understand it. Then the decoder on the right takes that deep understanding and starts writing the output, like translating it into another language. But of course, they didn't just stop with one attention mechanism. They came up with this brilliant innovation called multi-head attention. It's like having 8 different experts reading the same sentence all at once, but each one is looking for something different. You know, maybe one head is an expert in grammar, while another is great at connecting pronouns to people, and a third is just focused on the overall vibe of the sentence. It creates this incredibly rich, layered understanding of the text. But wait a second. If the model sees all the words at once, how does it know what order they're in? I mean, the cat chased the dog is a very different story from the dog chased the cat. This is where another clever idea comes in, positional encoding. You can think of it like stamping every single word with its own unique digital zip code that tells the model exactly where it is in the sentence. It preserves the crucial word order that would otherwise get lost. Okay, so we've got this beautiful new architecture built on this amazing idea. But did it actually work? Oh yeah, it worked. In fact, it didn't just work, it absolutely demolished the competition. So on this standard test for English to German translation, the transformer hit a score of 28.4. Now, that number probably doesn't mean a whole lot to you by itself. But you have to understand, in the super competitive world of machine translation, a number like that was basically an earthquake. That score was a jump of over 2 full points better than the previous record holder. In this field, researchers will fight tooth and nail for a point 1 improvement. Getting a 2-point jump all at once? That was completely unheard of. It just set a whole new bar for what was even possible.
And here's the real kicker. This is the part that blew everyone's mind. The transformer wasn't just better, it was also way, way more efficient. It got these record-breaking results using just a fraction of the computer power that the old models needed for training. The final scoreboard here really tells the whole story. The old champ, which was actually a bunch of models working together, topped out at 26.3. The transformer, just a single model, hits 28.4, and it did it with nearly 10 times less computational work. So higher quality for way less time and money. It was a total paradigm shift. But you see, this paper was never really just about building a better translation machine. What it did was give the entire field of AI a brand new blueprint for how to build intelligent systems from the ground up. So let's just recap the magic formula here. It could be trained way faster because it was built for parallel processing. It was amazing at understanding long sentences and documents, and on top of all that, it delivered better quality with way more efficiency. It was just a win-win-win-win. And this is the punchline. This is why that paper from 2017 is so unbelievably important today. Ever wonder what the T in ChatGPT stands for? Yep, it's transformer. The architecture from this one paper is the direct ancestor of BERT, GPT, and pretty much every single major AI tool that is reshaping our world today. So in the end, attention is all you need was so much more than just a clever title. It gave machines a fundamentally new, more intuitive, and just massively scalable way to understand our language. It kicked the door open for the entire era of generative AI we're in now, which leaves us with just one question, right? What are we going to build with it next?